What if I told you that there's an extremely old galaxy that has stopped creating stars and resembles a fossil of the early universe? This galaxy is so massive and compact that it could be compared to a huge fireball packed into a tiny space. Thanks to the James Webb Telescope, we have made a truly exceptional discovery: a large, compact, inactive galaxy that has completely ceased stellar production. This galaxy could be an ancestor of the huge elliptical galaxies we see today. The amazing thing is that this galaxy is surrounded by an equally spectacular phenomenon called the Einstein ring. This phenomenon occurs when light from a distant galaxy is deflected and amplified due to the gravitational influence of a nearby galaxy. This discovery not only raises many questions about why this galaxy stopped star formation so abruptly, but also makes us question what physical mechanisms are at play to regular star formation, and how this process feeds back into similar galaxies that are representative of the early universe. Join us on this journey to the deepest part of the universe, where we will explore this finding in detail, as well as other similar observations made by the James Webb Space Telescope. You will discover how this discovery was made with unprecedented resolution and sensitivity. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel, be sure to like this video, and turn on the notification bell. What is an Einstein ring and how is it formed? Before diving into the details of the fossil galaxy, it's important to understand the basics of this phenomenon. An Einstein ring is a special case of gravitational lensing, a phenomenon predicted by Albert Einstein's general theory of relativity. According to this theory, gravity is interpreted as the curvature of space and time due to the presence of mass. In other words, any object with mass can bend space and time around it, which affects the path of light passing near it. Now, imagine that you have two galaxies lined up in our line of sight. One is closer to us, and the other is further away. The closer galaxy acts as a kind of lens, bending and distorting the light from the farther galaxy. How the light from the distant galaxy is distorted, amplified, or even split into multiple images depends on factors such as the mass, distance, and alignment of these two galaxies. In exceptional cases, when these two galaxies are perfectly aligned, the light from the distant galaxy can form a ring around the closer galaxy. This phenomenon is what we know as an Einstein ring, and is one of the most impressive and fascinating phenomena in cosmology. In the case we are exploring, the Einstein ring surrounding this galaxy is one of the most complete and symmetric ever observed. It has a diameter of about 4 arcseconds, which is equivalent to about 20,000 light-years at the distance of the lensing galaxy. It is also very bright, with a total magnification of about 40 times. This means that without the gravitational influence, we would not be able to detect the galaxy at rest, as it would be too faint and small to be observed by the James Webb Space Telescope or other telescopes. The question that arises is, how did James Webb discover this Einstein ring, and what was the project that led to this amazing discovery? These answers will be revealed in the next section of our video. What is the Cosmos Web Survey project, and how is the James Webb Space Telescope involved in this project? The Cosmos Web Survey is an initiative to investigate a significant number, approximately 1 million, of galaxies using the James Webb Space Telescope. This telescope has 4 scientific instruments that make it possible to observe the infrared light of the universe with unprecedented resolution and sensitivity. One of these instruments is the Near-IR camera, NIRCam, which plays a key role in this project. NIRCam has the capability to capture images of space in 9 wavelength bands, ranging from 0.6 to 5 microns. In addition, it can perform coronography, a technique that blocks light from luminous sources, such as stars, in order to reveal fainter objects that may be close to them, such as planets. The Cosmos Web Survey uses the NIRCam camera to observe a large portion of the sky covering 2 square degrees. To put it in perspective, this area is equivalent to about 10 times the surface area of the full moon. This patch of sky lies in the constellation Sextans and is part of the Cosmos field, a celestial region that has already been studied by several other telescopes, including the Hubble Space Telescope, the Spitzer Space Telescope, the Herschel Space Observatory, and the Atacama Large Millimeter Submillimeter Array, ALMA. This study is one of the first to take advantage of the capabilities of the James Webb Space Telescope and has already generated remarkable results. One of the most outstanding discoveries has been the identification of the fossil galaxy mentioned above. But what are the specific characteristics of this galaxy, and how has JWST measured them? The massive, compact, quiescent galaxy, or fossil galaxy, is a particular type of galaxy that has stopped forming new stars and is considered a possible precursor to the giant elliptical galaxies. Giant elliptical galaxies are the largest and most massive galaxies in the universe, some located in the center of galactic clusters. These galaxies have a smooth, spherical shape composed mostly of old, red stars. They are rare in the early universe, since at that time, most galaxies were still in the process of star formation and had irregular shapes. However, the quiescent galaxy discovered by the James Webb Space Telescope is an extreme example of this type of galaxy. It has a mass of approximately 300 billion times the mass of the Sun, comparable to that of our own Milky Way. However, its size is remarkably small, at only about 1.5 kiloparsecs in diameter, which is equivalent to about 5,000 light-years, 20 times smaller than the Milky Way. This characteristic makes the galaxy exceptionally dense, with a stellar mass density 1,000 times greater than the average density of the universe. The extraordinary thing about this galaxy lies in its age, since it ceased star formation when the universe was about 1.5 billion years old, about 10% of its present age. This implies that most of its stars formed in a short and very intense period of stellar activity before abruptly stopping for reasons as yet unknown. Moreover, this galaxy is isolated, with no companions or signs of interaction with other galaxies. So, how did we obtain this information about the quiescent galaxy, and how did James Webb measure these properties? The answer lies in using the telescope's high resolution and sensitivity to observe the infrared light emitted by the galaxy. Infrared light has a longer wavelength than visible light, allowing it to penetrate dust and gas that can obscure visible light. This reveals crucial information about the temperature, age, and chemical composition of stars and galaxies. Using the NIRCam instrument, James Webb was able to resolve the Einstein ring into multiple images of the quiescent galaxy and measure its brightness and color in several wavelength bands. By combining these measurements with the magnification factor of the lens, he was able to estimate the age, size, mass, and star formation history of this quiescent galaxy. All these questions are challenges that the James Webb Space Telescope will attempt to address in the future as it continues to explore the distant, ancient universe with its extraordinary resolution and unparalleled sensitivity. What did you find most incredible about this James Webb discovery? Let's talk about it in the comments. If you enjoyed the video, remember to like and subscribe.